This is 2.2. We are looking at median and right bisector. So we have looked at two videos now that are in the content section. So we should have a bit of knowledge here already, so we can go a little bit quicker. Our goal is to know how to determine the equation of a line containing a median and to know how to determine the equation of a line containing a right bisector. Okay? So define a median. Does anyone remember from the lesson that we just watched what is a median? What is a median? It's right here. Did you come late? Why didn't you get a sheet? Nobody remembers? Median? Yeah, Andrew.
The median is the middle of a line to another line. For example, A to the middle of B and C.
Okay, good. So that would be a line segment that goes from a vertex or a point in the triangle to the middle of the opposite side, right? So from A to middle of B. Now this is not going to be perfect here. I'm just eyeballing it, but it's going to look something like this. Okay, there's my line. Here I'm going to draw a median from line A. Here we're going to draw a median from line B. So what do I have to do for this, Josiah? Where am I going to draw my line from? Sorry? You're plugging your phone in. Okay, look up at the screen. Where am I going to draw the line from? I want to draw the median from B.
To the middle of A and C.
Excellent. Now one way I could do this very accurately, right, is I could actually measure the line and then cut it in the middle, and that would be the midpoint. Okay, last one, draw a median from C. Rudy, what am I going to draw?
From C to A.
Yeah. All right, that's a little bit off, but basically these lines should be the same. Okay? All right. Example 1. Determine an equation for the line that contains the median from vertex C for the triangle with vertices C, A, and B. So here's my triangle. This is right from the lesson. Okay, so we're actually going to, let's skip this one because this is the one that he covered and we reviewed at normal speed. So we're going to skip that one and jump to the very next one, which is the same question with just different numbers, okay? But first, let's answer this communication. What is the difference between a midpoint and a median? Who can tell me that? Janir, you know this. What's the difference between a median and a midpoint?
The midpoint.
Sorry?
We found the medium first, and then we found the midpoint after when we were watching the video, right?
Nope.
We did that.
They're two different, no, they're two different things specifically. You know what a midpoint is? What is it? We've been doing it for 2 sections now. What's the midpoint?
Middle.
Yeah, the middle. The middle of what? On a line, right? It's the midpoint on a line, right? So it's the middle of a line. So if here we have a line here.
But didn't he say something like that in the video, though?
Say what?
I don't know.
He did say something like that. He talked about midpoint and median. Yeah. You need the midpoint to find the median, right? Let's talk about the median. So the midpoint is just the middle point of a line segment. All right. Now the median. Who can define it before I draw it? Liam, give me your best definition of a median. The midpoint of 2 lines? No.
The line that crosses
E-
the middle of like the triangle.
These are all medians, right? This is median from C, median from B, median from A. So just explain what that is, okay? In words, what is that? What is a median?
A line segment.
Yes, a line. Yep, segment, sure.
That passes from the midpoint to opposite side.
Good. That passes, let's say, from a vertex, which is the corner of a triangle, right? From a vertex to the opposite side midpoint, right? Not the greatest definition, but good enough, right? And then we have our triangle here. I'm going to draw this very rough. And so if we have this as A, B, C, our median for C would run from C to the midpoint between A and B. Make sense?
Yeah.
Any questions? All right, we know the difference between a midpoint and a median. Example 2. So this is the same as the first example. We just have some different numbers here. There's a mistake there. That should read C. Plot vertices of a triangle A, B, and C. Okay, so we should all be able to do this. A is -4, 2. That's A. B is 3, 5. There's B. And C is 1, -4. C. Okay. Draw the median from vertex B. So before I do that, I should create a triangle here. I think that makes sense. All right, there's my triangle. Now it says it wants draw a median from vertex B. So, Josiah, what do I do?
So add B the first one,
Yeah,
draw a line
yeah,
going down the middle.
good. Okay, there's my line. I see that's pretty off. I'm gonna have to try it again. Now, the easiest way to do this, if you guys are doing this yourselves in your book, if you have a ruler, watch. I can measure in A and C. You can see it's 5, so I want to do 2.5. There's my midpoint, and now I can draw. Okay. There, that's better. So this is now equal to this. All right, that's my median. Now it says determine the equation for the line that contains the median from vertex B. So what line am I trying to get the equation for? RC.
For AC.
What?
AC.
AC. No. Let's read it again. Determine the equation for the line that contains the median from vertex B. So which line do I want to get the equation for? Try again. So not this line, but you're right. M is on the line that I'm trying to get. What's the line though? M is a point. M, this line, right?
Yeah.
Yes, that's right. I want this line here. Why do I know it's that line? Because it says the median from vertex B. And this is what we describe as a median. So that's the equation of the line I'm looking for. Don't know what you're looking for, we can't find it. Yeah, Luke, Maxis?
Is the equation like the x1 plus x2 divided by 2 and then the y1 plus y2 like over 2?
No.
Like that?
No, the equation of a line is this, right? That's the equation of a straight line. Y equals mx plus b. Okay, so it wants us to find y equals mxb, mx plus b for this line here. All right? So how can we do that? It was done in the last example. KG, what do you think? My question is, how do I find the equation of this line? How do we find the equation of a line? What do we need? Yeah. We need the y-intercept? Yeah, that's probably the hardest thing to get, to be honest with you. Like, we can look at it here and it looks like 1, but we're not sure. We need to find for sure. So that's probably the last thing we get. Before, what's the first thing we usually get? Yes, Lucas. The slope, right. And so we have a cool fancy equation for the slope, which is, Rudy? Rudy, equation for a slope. Yeah? Good. Nice. So we have this fancy equation. Where am I going to get all these values, these points? y2 and y1 and x1 and x2. Yeah?
You find the midpoint of A and C first.
Right. And the reason why is because we have b. We know b is 3, 5. But we don't have the second point on the line. We don't know what m is here. So we need to find m first. So the first step we need to do is actually not the slope. We need to know what is point m. So point m is the midpoint of A and C. So how do we get the midpoint of a line? What's the formula for midpoint? It's from, yeah, Stefan.
Would it be x1 plus x2 divided by 2?
Yep.
And then y1 plus y2 divided by 2?
Excellent. Okay, keep going, Stefan. What's x1 and what's x2?
X1 would be -4,
Yeah. Plus.
and x2 would be 1,
Yes. Very good. y1?
and then y1 would be 2,
Yep.
and y2 would be -.
Excellent. Everyone saw where you got these numbers from?
Yeah.
Yes, I hope. Right? They're from these 2 points, A and C, right? We have them up here, A and C. These points. Those are the points he got. Okay, so let's do a little bit of math here. -4 plus 1 is -3 over 2. And then we have 2 minus 4 is -2 divided by 2 is -1. Okay, now we can check that real quick. We can eyeball it. Does that look about right? So we have -1.5 and then -1. It looks right on.
Sir,
So I know I drew my graph pretty well. Yep.
is it supposed to be -4?
No, it should be plus -4. So yeah, I skipped that little step there. I didn't do the plus minus, but it's plus -4. Yeah, sorry if that confused you. So it became 2 minus 4. I skipped that step. Okay? So now we have our m value. We also have our b value. I'm going to populate this in here. Okay? Now, how can we get our slope? Where's Teodi? How do we get the slope now, Teodi? I'm going to help you out here. It's rise over run, right? Which we know is y2 minus y1 over x2 minus x1. Okay? Now, we want the slope, remember, of this line. So the 2 points we want to deal with is m and b. So what do I put in here for y2? Teodi? Yeah, 5, right? You always, the y2 is the further one along, right? In the x direction, so 5.
5 minus -1 over 3 minus -3 over 2.
Excellent. So we get 5 plus 1 is 6. And then we get 3 plus 1.5, right? So we're gonna have, sorry if I can do this the long way here. We're gonna go 3 over 1 plus 3 over 2. So we get 6, right? Over 6 over 2 plus 3 over 2. We're going to get 6 over 9 over 2. And that becomes, so this is getting messy here without a calculator, but it's actually 2 over 9, which is 12 over 9, I believe. Someone do that on their calculator?
So don't you have to reduce it?
Yeah. Which is 4 over 3, right? So that's right. Okay, so all of that work to say m is equal to 4 over 3. All right. So now our slope, we have m, so we know y is equal to 4 over 3 x plus b. Now we don't have b. Like we could look at the graph and say, oh, b looks like 1, but we need to find out b precisely. So how can we get b now? Max?
y1 minus y2.
No. How to get b? Should be easier than that. There's no formula. Who knows how to get b? Good, nice, some guys. Yeah.
You plug in the coordinates.
Which coordinate? A? No. A wouldn't work. You're right. We have to plug in a coordinate, but not A. Why not A? Why not A, Jafet?
Because that's not the line that we're looking for.
Right. It's not on the line we're looking for. We're looking for this line. Yeah, B. B is going to work. And we prefer B to M because it doesn't have a fraction. So let's plug in B. So go ahead, Douglas. What am I going to plug in for Y?
5
Yep. 5 equals 4 over 3.
and x plus 3.
Yep. Plus b. Okay, these 3's will cancel. So I get 5 equals 4 plus b. We get b equals 5 minus 4. 1 is equal to b. Therefore, our line, finally, is y equals 4 over 3 x plus 1. And we can check that on our graph, and it lines up pretty good. Any questions?
Sir,
Yeah.
can you go over how you give the brackets for finding the slope?
Here, this stuff?
Yeah, down there, like 6 divided by 6.
Okay, sure. So 6 was always on the top. To deal with this fraction on the bottom, I wanted to get common denominators, so I made the 3 6 over 2. Does that make sense?
Yeah.
So I made the 3 6 over 2, and then I added it to the 3 over 2 because it was minus minus. So now I'm just adding 6 and 3, so I get 9 over 2. You see that?
Yeah.
And now when you divide a fraction, you actually multiply by the reciprocal. There's that word again. So you flip them, and so it's 6 times 2 over 9. So now it's 6 over 1 times 2 over 9. So you get 12 over 9 and reduce 4 over 3. Okay? When you divide by a fraction, you flip it. Okay? That's like I think grade 8, maybe? Okay? Any questions there? Other questions? All right. Moving right along, hopefully with some time left. That's my goal. We're defining the right bisector. Who can define it without this? Who's confident? What is a right bisector? We talked about it at length. Engineer.
Right angle?
Yes? It's a right angle to another line, and there's something else that's unique about it.
The negative reciprocal.
now that's to do with the slope. You're right. When two lines are perpendicular, they have negative reciprocal slopes. But for a right bisector, it's a right angle, and it Nokia's?
Across the midpoint.
Yes. Good, my man. Crosses through the midpoint. That's it. Those are the two things. Okay? So it passes through the midpoint and it intersects at 90 degrees. That's what makes a right bisector, right? There's 2 points for it. Right, so right angle, bisector, passes through the midpoint. That's what a right bisector is, okay? So here we want to see in example 3, determine an equation for the right bisector of the line segment with endpoints A and B. So here, we have this line, pretty simple here. Determine the coordinates of the midpoint M of AB. So it's giving us the steps, step by step, how we're gonna get the right bisector of this. Let's just graph this out quickly. -3 and 5. Okay, that's A. And B, we have 7 and -7. Here is B. Oh, sorry. There they are. A and B. Okay. And it's asking for an equation for the right bisector of this line. Okay, so it doesn't want the equation for this line. It wants the equation for... Let me try and make it a little bit better. That's 6, so I'm going to try and draw it a little bit accurate. So it wants the equation for this line. This is the right bisector. There's my middle point. Okay, so what is y equals mx plus b for this line? Does that make sense, guys? It's asking for the right bisector. Make sense? All right. Now, we're going to get all the steps here. So it says, first, determine the coordinates of the midpoint M of AB. So here, AB, we need to get the midpoint M. So what is M of AB? The equation for that. I know Stefan knows it because he helped us last time. Yeah.
So we get x1 plus
Yep.
y1 y2.
Okay, keep going. What is it? What's x1?
So x1 is -3 and x2 is 7. Y1 is 5. And y2 is -7.
Okay, and I'll finish this off for you. We get okay, there's our midpoint, 2, 1. Determine the midpoint. Okay, we got that. Next, determine the slope of the line segment AB. So why would we want the slope of this line? When we're trying to get actually the slope of this line, why do we want the slope of this line? Yeah,
Because the slope of the other line is the negative reciprocal.
yes. Look, he's killing it today. So he knows if I get the slope of this, because I already have 2 points on this line, then I can do the negative reciprocal and it'll be the slope of this line. That's why. Determine the slope of the line segment AB. So how do we do that? I want little m now. What's the formula for slope of a line? Someone yell it out?
Y equals mx.
Nope.
Oh.
Okay, now we need to use points A and B for this though. So who can keep going with this? Tell me the values of y2 and y1 I'm going to use here. Yep. Sure.
-7 minus 5 over 7 minus -3.
7 plus 3.
So we get 7 plus 3 would be -6/5. Any questions? No? Good. Determine the slope of the line that is perpendicular to AB. So Milkias, you told us why we needed that slope. Now, finish it off and tell us what is the slope of the line that's perpendicular to AB. We're going to do this. M with the perpendicular sign is equal to what?
5/6.
Excellent. Is that positive or negative?
Positive.
Excellent. So a little bit of magic there, and we have the slope now. So we know the slope of this line here is 5/6. Down here, 5/6. All right, so we got the slope of this line. We got a point on the line. Is that enough to give us the equation of the line?
Yeah.
The slope and a point? Is it enough? What do you think? Adrian, you got a point and you got a slope. Is that enough now for us to do some math and get the equation of a line? You're right, but can we get that with what we have?
Yes.
Yeah, we can figure it out, right? We can figure it out. Okay, so how are we going to do this? We know the equation of a line equals y equals mx plus b. Okay? We know that our slope here is 5/6 plus x plus b. We also know that our m point, which is on the line, is 2, -1. So we can take that m point and plug it into this equation now. So I'm going to plug in -1 for y, and I'm going to plug in 2 for x, and I'm going to solve for b. Okay, so I have -1 equals 10/6 plus b. We're going to have b is equal to, I'm going to get a common denominator here, just because I don't have a calculator, so we're going to go with -6/6. That's my 1 minus 10/6. So we get b is equal to -6 minus 10 is -16/6. And we can reduce that. B is equal to -8/3. Okay, now let's look at our line. Does that sound about right? 8/3. So 8/3 is just over 2, right? No. Is that right? 8/3. Yeah. Oh, I was looking down here. Y-intercept. -8/3. Oh no, that looks totally wrong. Should be, maybe I drew this line wrong. Should be down.
Sir,
Yeah?
it's because you estimated first. It's not.
Because what?
You estimated like the line first. We didn't find the midpoint of AB. We find the midpoint using like algebraically after you drew the midpoint.
Yeah, like this is drawn wrong basically. Yeah, you're right. You're right. So let's just finish this off so we know what the equation is. Our equation of our line is 5/6x minus 8/3. That is the equation. That is the correct answer. Unfortunate it doesn't line up. What is 8 divided by 3? Can someone tell me? 2.6. So actually, it's like more like down here where it crosses. So it's more likely that I missed the bisector. It's like that. See that? I was too far to one side. Yeah, it totally was. It should have been right here. My bad. But anyways, the math does not lie. That is the correct answer. Any questions on how we got to that? Construct the line segment AB and right bisector on the grid. So that would have been this one here. And I would have known that based on the y-intercept and based on the midpoint. Yeah.
How is it -1 and the equation turns out -6 over 6?
Say it again. How is what?
You see how you want the -1 equals 10 over 6 plus b?
Oh, here?
Yeah, how did it turn to -6 over 6?
Because -1, I found a common denominator of 6. So basically, I took the 1 over 1 and I multiplied top and bottom by 6. So it became -6 over 6. Okay? Yeah, again, fraction. It's just old fraction math. And then I'm doing -6. I just, remember when you work with fractions, you just work with the numerators when you add and subtract. So the 6 stays the same. So it's -6 minus 10 is -16. Right? I know this stuff you guys can forget, but it's still important. All right, the last one is the one that he covered in the video. 2 schools are located at P and Q. Okay, so I'm not going to redo it there. I'm going to stop the video there. If you want to review the answer for that, he did a good job on the video explaining that question. Stop it there.